Hey guys, welcome back to our third and final video for U-Substitution for polynomials. I want to say that I'm going to do two examples here, and one of them is we're given the substitution for U. They're telling us what we wanted to use for U, and we want to be able to rewrite this and see which one of these functions this is actually equivalent to. So without further ado, we're going to do this question. And what I end up doing for this particular question right off the bat is I go ahead and start writing like this, and I want to just start substituting in. So I know right off the bat that the square root of x plus 1, right, the square root of x plus 1 is u. So I'm going to go ahead and write u down here. And I'm going to go ahead and just kind of get rid of this, because now that I have it substituted in. And while I'm still in the denominator, I know that I got to find what x is. So we actually talked about this previously on how to find x. So if u is equal to the square root of x plus 1, I can go ahead and square both sides, because ultimately what I want to do is I want to solve for x. I want to know what x is in terms of u, and that's always a good case. And like I said, we've done an example of this in the very first video, so we're just going to look at it again. So x is going to be equal to u squared minus 1. So think about this as maybe like y equals the square root of x plus 1, and you have to find the inverse where you flip x and y. Well, this is what you would end up doing. So I can go ahead and replace x with u squared minus 1. And so now I can go ahead and get rid of the u. The next thing I can do, ladies and gentlemen, is I can change my bounds. So when x is equal to 0, because again, we're looking at x's here. When x equals 0, well, now we go back to our function here. When x is equal to 0, u is going to be equal to the square root of u plus 1. Again, I'm going back to this function right here. So u is going to be equal to 1. So I'm going to go ahead and put a 1 here. When x is equal to 3, u is going to be equal to the square root of 3 plus 1, right? I'm plugging in x there, which is going to give me the square root of 4, which is going to give me 2. So this is going to give me 2 here. So I'll go ahead and get rid of that. Now, what you can then do is figure out what dx is. So if you see this example right here, this very simple problem right here, I can find this derivative pretty easy by using implicit differentiation. So I can go ahead and take the derivative of this implicitly and say that 2u, so the derivative of u squared is 2u du, right, is going to be equal to, because the derivative of negative 1 is 0, the derivative of x is just dx. And so dx is actually simply equal to 2u dx. So I can go ahead and write up here 2u du. And once I do that, I can cancel the u's, and I'm left with the integration from 1 to 2 of 2 du all over u squared minus 1. And I can pull the 2 out, because you don't have to, but you can pull the 2 out if you want to. So both of these are equivalent to each other, and that's going to give us the answer, which I didn't have to do it anyways, but the answer is B. Another way of doing this when we get to more complicated stuff is you could have found the derivative of this by going and saying du, and then taking the derivative of this as 1/2 x plus 1 to the negative 1/2 power times 1, because again, the chain rule, even though we didn't do it, I still want to put in there, times 1 dx. So then, and again, this is a lot more complicated, but du is equal. I'm just going to show you guys that it works both ways. So some of you are like, why don't we take the derivative here? It doesn't matter. You could take a derivative of any of these. So we're going to be left with du, and then this is going to be 2, and then I'm going to go ahead and bring down the x plus 1 to the 1/2 dx. And if I solve for dx in this case, I get dx is equal to, I'm going to cross multiply, 2 square root of x plus 1 du. Well, you guys realize that these are the same two things, right? So the 2, there's your 2. The square root of x plus 1 is equal to u. We talked about that at the very beginning. And then there's the du. So it doesn't matter which one of these you implicitly differentiate. You're always going to get back to this problem right here. You're going to still get back to, in this case, 2u du. So you can do the middle one as well. It doesn't really matter what it is. So we have now marked out every single thing right here, and now we've replaced it, we simplified, and we get the answer, which again is B. All right, we're going to do one more example, pretty short one for you guys to see. All right, so looking at question number 7, we're integrating the square root of x plus 1 over the square root of x dx. Now, the easiest way to do this, is rewrite your numerator. Rewrite your numerator like so. And then just look at the problem is 1 plus x to the negative 1/2 dx. And then integrate this. So much easier, wonderful way of doing it, right? This is very easy to do. We're going to get x, because the integration of 1 is x, and then we're going to get x to the 1/2 power 2 plus c, right? So x plus 2 square root of x plus c. 100, fantastic way. But if we want to use u sub, and I haven't really talked about this yet, but usually when you have a rational function, usually your u is your denominator. But in this case, our u is actually going to be our numerator. Because this still works out. We can still do the problem the same way. So if we make u equal to the square root of x plus 1, I can take the derivative of the square root of x, and that's going to give me 1 over 2 square roots of x dx. Right? So it's 1 over 2 square roots of x dx. So I can go ahead and cross multiply the 2, and I just want to show you guys really quickly that this is the du. So it's weird and odd, but the du is this denominator and the dx. So when I rewrite this, when I rewrite the problem, I'm going to get 2 integration. This is u, and then this is our du. And so now this is actually much easier to integrate, but it's up to your choice of what you want to do with the problem. But this is what you would end up having to do here. And so we're going to go ahead and integrate this. We're going to get, so why am I writing the integration again? We're going to integrate this. And so we're going to get u squared over 2. U squared over 2. And then we're going to do a plus c. So I'm going to get that this is going to be u squared plus c, which then gives you, by substitution back in, the square root of x plus 1 squared plus c. Okay? So when you FOIL this out, you're going to get x plus, multiplying the double, 2 square roots of x plus 1 plus c. And so I don't know if any of you guys are wondering, like, okay, hold on with this. Notice that this and this does not exactly match. But just like in the previous question, ladies and gentlemen, if I do c plus 1, that becomes our new c. So all we really care about right now is going to be the fact that our function is still the same thing. It's still the same thing. So this c here and this c here, it's just plus c. So if you take the derivative of this whole function or this function, you are still going to get this back. So both of these functions, as you guys can see, are the exact same thing. So it doesn't really necessarily matter what the constant is. It really just matters that the function is this. You take this derivative, you are going to get that crazy thing back if you start simplifying. All right, so the last thing I want to do in this actual lesson is just really quickly just show how to set this one up. We did one of these questions in the very first video, so we'll talk about it again where, okay, let's look at our functions here because it may not be completely obvious what to do. So if we look at two functions, again, your best bet is to always make u underneath your radical. I'm already trying to take the derivative, I don't know why, but underneath the radical, so it's going to be 1 plus x squared. And so our du is going to be equal to 2x dx. Okay, 2x dx. So we don't have a 2 here at all, so we're going to go ahead and do a 1/2 du equals x dx. All right, so let's start substituting in of what we have. So we have a 1/2, and this is our u. This is our u, so we have the square root of u. We have one of the x's. Right? We have x and then dx. We have another 4 x's to deal with. So just like in the previous example that we did, we can isolate x squared. So let's go ahead and do u minus 1 equals x squared. And so then if we square both sides, we get x to the 4th. So in previous examples, we want to be able to write this in terms of x, or in terms of u rather. So we're going to do u minus 1 squared du. Remember, one of our x's is already right here, so we only want x to the 4th. We don't have to go ahead and do x to the 5th. So this is what you would set this problem up with. And so in order to solve it, and again, this is where we're going to stop, but we would do u to the 1/2 here. We would factor this we get u squared minus 2u plus 1 du. You would distribute this, and then you would integrate it using the power rule. All right, but just to show you guys an example of, again, if you have an extra x or x squared or x to the fourth or whatever, then you can use this right here to most likely get that relationship. So you can go ahead and substitute in. All right, so that is lesson number 14. I will see you guys here when we start dealing with trig functions in the next lesson.